let's design a sum function in recursive manner. So in doing so, let's create myutil class. myutil.h pragma ones class myutil public static, so that we can call the function without creating object of myutil. Return type some parameter is through that integer we are going to add. So here 0, 1 up to n provided as a parameter. myutil.cpp myutil sum function through integer n. So when you design recursive function based on the mathematical induction, you can interpret the mathematical induction as follows. So in mathematical induction, step 1 is solve for smallest possible n. Solve for n is 0 or 1, like a smallest one. In a recursive function, step 1 is same, just solve for smallest n with 0 or 1, whatever it is. That's the same. So let's write that part. If n is 0, return 0. So this is a base case solution, a direct interpretation from mathematical induction. Prior to this one, you may want to assert the validity of n, and should be 0 or positive. We need to include C assert library for assert the function. And then in mathematical induction, next step is inductive step. What you do is using induction hypothesis and then show that n plus 1 size. So induction hypothesis, so solution for n is available, or the statement satisfies, assumes that statement works for n, then show next size n plus 1. So that's induction hypothesis. In recursive programming is we need to understand what is induction hypothesis. We are solving for size n, so induction hypothesis means any smaller size solution is available. So n minus 1 or n minus 2, any smaller size of n is solution is available. That's the meaning of induction hypothesis. So what is a solution in my design? In our design of a recursive function for sum, solution is when given size, as we call function. If I call function with a 10, then that's a solution for size 10. So induction hypothesis means any smaller size solution is available, means within this solution you can call some function with any smaller size. For example, minus 1 or minus 2, just calling smaller size problem solution is induction hypothesis. Then show that how to solve for size n. So in some function, solution for size n is suppose I know how to solve size for n minus 1, which is sum of integers 0 through n minus 1. Then solution for n is if I simply add the n, This is a solution for size n. So induction hypothesis, this part is a known factor. So we can write the code directly there. So else return induction hypothesis, any smaller size solution is available. For example, sum n-1 is available, then solution for n is some function called n-1, and if I add the n, that's the solution for size n. So this is a recursive function design. So let's verify how this works. Let me erase the screen. Then let's create make a file. There. So we want a.out or a.exe if you use Windows, main.o, my util.o is the one I need. Then put together main.o and my util.o. To create myutil.o, I need to compile myutil.cpp, which include myutil.h. Compile only myutil.cpp. And then main.o, I need to compile main.cpp, which include myutil.h. Compile only debug symbol main.cpp. So this is a make a file. Let me open terminal and compile it. Here the myutil.cpp line 5 function sum requires a type specifier. Here when you design a function, I need to give a return type and then function name. Compile, it runs. Okay, so in main function, sum of integers 0 through 10 is 55. So you can assert that this is a 55. Assert requires C assert library. Then another test point, the sum of integers 0 through 100 is 50, 50. That's the one. So let's compile and run. So those two are tested. Now let me show you how this actually works. So let's trace the program execution. If I call sum, for example, 4, then it get into this one, n is a 4, so it's not 0. We go this part, that is we call sum n-1. So this one is a sum n-1 plus n. So sum n-1, sum 3 is called, so we keep calling this one recursively. So what this call means is a sum n-1 plus n. Sum 2 in turn calls a sum n-1 plus n. Sum 1 calls a sum 0 n-1 plus 1. Now sum 0, let me change color, sum 0 returns a 0. That is this part. Then 0 plus 1. 1 is returned as a function called sum1 is 1 plus 2. 3 is returned for sum 2. 6 is returned, and 10 is returned for sum 4 call, which is a return value of a sum 4. So that is a 1 plus 2 plus 3 plus 4 is a 3, 6, 10 is there. That's the trace of a recursive function call.